Hi, my name is Lucy, and today my talk will focus on describing a strategy we use to develop a vaccine for malaria. Malaria is an infectious disease caused by a parasite that is transmitted to humans by mosquitoes. It causes millions of infections each year, and as such, it's a major global public health concern, and an effective vaccine remains urgently needed. The malaria parasite is a complex organism that makes vaccine development difficult. In our lab, we believe a potential solution is to use virus-like particle vaccine design. So, what are virus-like particles, or VLPs, and how do they function as a vaccine? VLPs are small particles that resemble a virus in structure, but importantly are not infectious. To make a vaccine, we can alter the surface of the VLPs to display many copies of a small portion of a pathogen, and by doing so, we can direct the immune response to make antibodies specifically against that portion of the pathogen. For malaria, seen on the top left of the slide, if we zoom in on its surface, we see that it's coated by a protein called CSP. This protein has an important function for the parasite. It helps it infect our liver cells. Zooming even further, we come across a critical region on this protein, a potential Achilles heel. This region is adjacent to a site that makes initial contact with the liver, and this region is small enough to be chemically attached to the surface of the VLPs. Using this approach, we can decorate VLPs with many copies of this critical region. When we immunize with these VLPs, our bodies can then generate antibodies that are directed specifically against this critical region, so that the next time someone is exposed to malaria, they already have high levels of antibodies against this region that can then prevent the parasite from infecting. Lastly, to show that this approach works, we first test this vaccine in mice. We immunize them and then infect them with the malaria parasite. We've shown that following immunization, mice make antibodies that significantly reduce infections compared to those immunized with a control vaccine. We have also shown that in mice, these antibodies remain in circulation for a long time. Long-lived antibodies are important for those who live in regions of the world where they could be exposed to malaria multiple times over their lifetime. So in conclusion, we believe that using virus-like particle vaccine design targeting small but critical portions of the parasite could lead to a successful anti-malaria vaccine.